All right, this is Calc D Notes 1, page 2, and we are reviewing stuff. So remember, there's really two sets of math analysis notes that you should have reviewed already that would give you the background information. This is just confirming basically that you went back and did that. So if the stuff here doesn't make sense to you, you got to go look at those notes. Those are notes 17 and notes something else that I can't remember. Probably notes 11, I think, is my guess, but it's just a guess. Might be 12. I don't know, something in there. You'll find it. Two-dimensional vectors. So let's see what we got here. So we want to find, we're given a vector. We want to find the norm, a unit vector parallel to the given vector, parallel with the mag. All right, let's just do it. So the norm has a weird notation. It's like double absolute values, kind of. And it's just, so you remember when you handwrite, you put a little arrow, and it's really just distance formula. So it's 3 squared, negative 2 squared, and then 5 squared. So what is that? 9, 4, 25. So radical something, 38, I think. Okay, so that would be the norm of the vector. On your calculator, that's menu 7, enter. Menu 7, enter. And make sure you know that. Make sure you can do that fast, right? So I'm gonna do those at the end of this problem, but that's how you can find it on the calculator. So unit vector parallel to the vector A. So remember, unit vector is just a vector divided by its magnitude. So that's going to be A divided by the magnitude of A. And we just found the magnitude of A. So you can scalar multiply a vector. So really what we're doing is 1 over radical 38, and then times 3, negative 2, 5. I would never really show this work. I'm just showing it this time because first time in these notes that we've done this. So 3 over radical 38, negative 2 over radical 38, and 5 over radical 38. This 5 is like really tight. That looks terrible. 5. Okay, so it's a vector divided by its magnitude. Everything is based on unit vectors, like everything in the world. So you got to know that vector divided by its magnitude gives you a unit vector. Very nice. One of the really useful things about unit vectors, so this, is we can create a vector with any magnitude we want as long as we start with a unit vector that we'll just scale it up or scale it down however we need. So here, we're going to be parallel. So that's just in the same direction, meaning they just have the same unit vector. And we need a magnitude of 5. So we're going to get B is going to be 5 times A over the magnitude of A. So A and B are going to have the same unit vector. So this is going to be, I'm going to do it as I go. So 15, so 3 times 5 over radical 38, negative 10 over radical 38, and then 25 over radical 38. When I do it on the calculator, it's going to rationalize. I hate it. It just rationalizes everything. There's really nothing you can do about it. All right, so that's if we wanted, if I needed to have a magnitude of 50, I would multiply by 50. If it needed to have a magnitude of 1/5, I would multiply by 1/5. Like you just scale it up or down, whatever you need. Unit vectors are the key to making that happen though, and that's a vector divided by its magnitude. Vector W, the exact opposite direction to A, and a magnitude of 12. So W, I need it to go in the opposite direction. So it's going to be numerous ways you can think about this. So instead of using this unit vector, we could just use the negative of that unit vector. What I'm going to do for my work is I'm going to say this is negative to flip the direction, 12 to give it the magnitude I want, and then A over the magnitude of A to give it kind of the real direction that I want, right? So this is just saying opposite to the direction of this unit vector. If it was like this is because there's a implied plus there, we're going in the same direction as that unit vector. So this will be, what do we get here? So negative 36 over radical 38, 24 over radical 38, and then negative 60 over radical 38. So I use these chevron deals. Some people use brackets. Doesn't make a difference. Some people use parentheses. I find that very confusing. I like to have a distinction between my vectors and my points, even though it's like a very, very tenuous distinction. I like to have that anyway. All right, I'm gonna do this problem, then I'll do everything on the calculator, and then come back in the next video and do more. So we want to write the components of the vector v from A to B. So A is the initial point and B is the terminal point. So we do terminal minus initial. We want to write it each as a linear combination of ij and k, so that's fine. Even if I have to write my answer using ijk, the unit vector notation, I'm gonna like do it in component form because that's just what I do. So v is the vector from A to B, which is going to be, so remember, it's b minus a. So it's 14 minus -3, then 2 minus 5. So it's terminal minus initial. So in this case, v is going to be 17, -3, -9. I would, ooh, that's wrong. I would anticipate me making a lot of arithmetic mistakes in these because that's what I do. So 17i minus 3j minus 7k. We'll check that on the calculator. And then here, it's like the same thing. So I don't really know why I don't know. You need practice, right? So 9 minus 4, 1 minus 1, -3 minus -3. That's kind of interesting. So this vector is 5, 0, 0. So it's just 5i. You gotta be really careful when it's just one component. Like make sure when it's written in ijk form that you really know which is which. So just in case you've forgotten, I is 1, 0, 0, defines the x-axis. J is 0, 1, 0, defines the y-axis. And then k is 0, 0, 1, your z-axis. So this, you know, x, y, and z. So let's go to the calculator. Let's just have the calculator spit out all these answers, and then we will call it a video and then return to do the rest. That was wrong. Hold on. I don't know what I shared. Oh, what did I share? Maybe I shared nothing. I don't know. Oh, you know what it is? My calculator is just on a different page, on a different display. It's probably fine. All right, I'm going to store the vector A. Let me move this. All right, hopefully you're seeing this because I don't want this to ruin the video, but it was on my second display, and so it like just straight up went missing for me. I'm going to start a new problem. Doc 4, enter. A is going to be 3, -2, 5. All right, so norm, menu 77, enter of A, radical 38, which we were expecting. All right, unit vector, I could do A divided by the norm of A. And I get this, it rationalizes, it's really annoying, but there's nothing we can do about it. Or I could do menu 7, option C is for vector. So menu 7 C or menu 7 up, and then unit vector of A. And you get the same answer, it doesn't matter. So then I can take that and I can do 5 times the unit vector of A to get this. So that's equivalent to what we have, just it rationalizes and there's nothing we can do about it. And then for W, we just do -12 times the unit vector of A. And we get this. So, and it rationalizes. So a weird thing is we could have done, you know, it's not weird, it's just ew. -12 times. I could have done -12 times the unit vector of this because these have the same unit vectors. I'm going to paste this down and you can see we get the same answer. It's the beauty of unit vectors. So a unit vector has a magnitude of 1, which means we can force it to have whatever magnitude we want by just scaling it, scalar multiplication. And then the last problem was, I guess, I'm going to add a problem, but so A is the vector -3, 5, 8. B is the vector 14, 2, 1. And so if I make the vector V is B minus A, I get 17, -3, -7. And then what can we do? So we can, if you wanted to, you could define I as 1, 0, 0, J as 0, 1, 0. I would not do this, but you can. 0, 0, 1. And then we can do 17I minus 3J. This is what it means for it to be a linear combination. Minus 7K. And then just see that we get the same thing. So, I mean, it's not pointless, but, you know, it's a little weird. 4, 1, -3. Component form for me is the superior form. I'm sure that there are people who do other things where, you know, other forms are more useful to them, but I don't. B minus A. 5, 0, 0. So this is 5I, 0J, 0K, which gives us 5, 0, 0. All right. So I'm going to stop this here, and I will go back to the notes, and then I'll be back in the next video to do some more. Probably finish this page. Better finish this page. Well, I mean, not better, but hopefully finish this page. But there you go. There's also, you know, sometimes throughout the notes, there's screenshots of the calculator just in case, but I think if you're watching the videos, you're probably getting it. So anyway, I will see you in the next one.